Hi, in this lecture let's talk about addition and subtraction of matrices. Addition of two matrices A and B is defined or compatible if and only if they have same order. So the order of both A and B has to be same. We saw the same case in case of equality of two matrices where the dimension of both the matrices have to be equal in case we are checking the equality of both matrix. So also for addition, the dimension have to be same. Now if the dimension of both the matrices are same, addition of A and B is obtained by adding the corresponding elements of A and B. Let's see it through example. So suppose A is Aij and B is Bij. So then A plus B is defined as adding the corresponding Aij and Bij. The resultant matrix will also have the same order of A and B. Okay, let's see it. Let's try to understand through an example. We have A as 1, 2, 3, 5 and B as 4, 6, 7, 8 and we need to find A plus B. So A plus B will be 1 plus 4, so that is 5, 2 plus 6, that is 8, 3 plus 7, that is 10 and 5 plus 8, that is 13. See that the dimension of the resultant matrix is same as A and B. Let's see some handy properties of addition. Matrix addition is commutative. It means that it doesn't matter how you add A plus B or B plus A. Both of them are same. Matrix addition is associative. So it means that So it means that A plus B plus C is same as A plus B plus C. So it doesn't matter how you add. You can add C to A first or B or C first or A or B first. It doesn't matter. Existence of additive identity. For addition, as we discussed earlier, null matrix, that is O, acts as the additive identity. So it means that if you add O plus A or A plus O, you will simply get the matrix A itself. So O, that is null matrix, acts as the additive identity in case of addition. Additive inverse. Suppose we have some matrix A. So we define A as Aij, which is having a dimension of m cross n. So suppose we define a new matrix minus of A as minus of Aij. So we are just negating each and every element from A. Now if we add A and minus of A, we will get a null matrix. So each and every element cancels out each other. So minus of A in this case is called the additive inverse of matrix A. So let's conclude this. We have one matrix A and we define minus of A, which is obtained by negating each and every element from matrix A. When we add A and minus A, if we get a null matrix, then minus of A will be called the additive inverse of matrix A. Simple. Cancellation laws. So this is interesting. Suppose there are three matrices A, B and C, and you write it as A plus C equals B plus C. So in this case, A and B will be equal. So this is called right cancellation. One more. C plus A equals C plus B. So in this case also A will be equals to B. So this is right cancellation and this is left cancellation. Okay, and finally A plus X, an equation A plus X equals 0 or null matrix has a unique solution in case of m cross n matrices. It means that there exist only specific values of matrix X for which A plus X will be 0. Okay, so that means that there will be only unique solution in case of m cross n matrix. Let's talk about subtraction. Let's talk about subtraction of matrices. So we have A and B as two matrices. Difference between A and B is obtained by subtracting each element of B from each element of A. Just understand that each element of B has to be subtracted by each element of A. Also, their order, that is the dimension of A and B, has to be equal. So suppose we have A as 1, 2, 3 and 4 and B as 0, -1, 2, 1. Okay, that's easy. So we will find A minus B as, or simply you can write it as A plus of minus B. So you can write it as 1 minus 0, that is 1, 2 minus of minus 1, that is 2 plus 1 is 3, 3 minus 2 is 1, 4 minus 1 is 3. So this is a subtraction of matrices. So here I want to make a note that subtraction is neither commutative nor associative. So it means that you cannot write it like this: A minus B equals B minus A. So this is not at all equal. Also, A minus B minus C is not equals to A minus B minus C. So both of them are wrong. Subtraction is neither commutative nor associative. That's it for this lecture. In the next lecture, we will talk about scalar and matrix multiplication, and we will solve some examples. In the description, I have added links to my website. You can go there and check out some other articles. Also, I have added links to the handwritten notes. You can download them and use them however you may like. Also, check out my Facebook page. You guys are really motivating me to make some amazing videos.